Now we come to our next speaker for today, who is in himself a corporate leader, a global corporate leader par excellence. Adarniya Sujay Kumarji is the current global AI head, AI data leader at Axion Labs. Adarniya Sujay Kumarji is somebody with a very diverse portfolio in the sense that you would have seen that he has served as an ex-senior software scientist at the Center for Artificial Intelligence and Robotics, in addition to being the ex-vice president business development at the global MNC Nest Digital Engineering, which we already know is responsible for the finest and the most sophisticated artificial intelligence advanced tech solutions ever created. He has also been the ex-head business development at the ITC Infotech, uh, a global corporate leader in big data, cloud engineering, mergers and acquisitions, AI, business strategy, and so much more. We're incredibly fortunate to have Adarniya Sujay Kumarji addressing all of us on high performance computing in today's CEI Masterclass. So, without further ado, I would now hand over to Adarniya Sujay Kumarji to please take today's session forward and address us on high performance computing and more. Ji Adarniya Sujay ji, Om Namah Shivaya.
Om Namah Shivaya. Thank you so much. So, Suman, um, do you have the presentation which you can share on your screen?
Yes, Sujay, Suman here. Yes, I do have your deck. So, Shraddha ji, can you allow me to share Sujay's deck? Yeah, perfect.
Absolutely.
Yeah.
Ji Suman ji, Om Namah Shivaya.
Sujay, can you see my screen?
Yes, I can. Thank you. So, good evening, good afternoon, good morning, wherever every one of you is. And what I'll do is, and thanks to Suman, you call him Suman Ji, Suman, whatever. He's a very close friend of mine, and he requested me to talk about this particular area. And I just want to admit that I'm not an expert in this area. Okay, I'm not someone who has spent several years in this space, but I have experienced this very early in my life, as a student, as a learner in my life, and also I will walk you through my personal experiences and try and have some sort of a storytelling semblance here with respect to what is happening in high performance computing. And then also, I will not go into the details of the technology, but I will explain to you what is happening in the space. Why is this space exciting? And how the younger generation should look at what they can do in the space and perhaps contribute to the society in a different in different ways, right? So that's my thought process here. So if you can go to the next slide, please. So I just wanted to kind of give you an idea of where technology is leading today. And then what I have done is I have basically done an aggregation of information from different places and try to again just create a semblance of information so that you get an idea of what is happening in the space, right? So now you just look at it. Um, when you're talking about internet creating roughly one internet user creating roughly 1.5 gigabit of 5 GB of traffic, data per day, or you're talking about hospitals generating 3,000 gigabytes of data per day, or a self-driving car. These are enormous numbers, okay? And on the right side, when you look at an example of a self-driving car, and if you look at all the components which generate data, right, from let's say radar, sonar, GPS, lidar, cameras, car, 1 exaflops per hour of compute processing is happening, and 1 exaflop is 10 to the power of 18 flops. which is basically floating points per second. That's the way you calculate the processor's compute power. So it's an enormous amount of data which today is getting processed, and it'll keep growing. It'll keep growing significantly as more and more digital we become as humans. I mean, more and more we embrace the power of digital as humans. So I think it requires a way to process these information. It requires way to make it much more accessible. Right now, it's the whole concept of high performance compute is very, very coveted. It is only done at R&D centers in large government institutions, etc. But now it's percolating down. It's becoming more and more accessible to users or data scientist community, etc. So we'll talk about that more. Can we go to the next slide, please? So why are we talking about HPC? So I'll give you one interesting example, and I also want to make sure when I share my stories, I share more of my stories of mishits or missteps or failures, because I think we all learn from failures. I mean, failures are the experience which we should cherish all the time, right? So my first introduction to high performance computing was way back in '96. I'm sure the folks on the call are people born in the '90s perhaps, or late '90s, or maybe even early 2000s. So you are Gen Z, Gen Y. I don't know which category you fall in. But there was we as a students, we were watching a movie called Disclosure, which is a movie in which there were two, Michael Douglas and Demi Moore are the two people who were actually part of that movie. And interestingly, they show a scene in the movie where they're using virtual reality as a mechanism to browse through some files. And leave aside the whole movie, that scene of maybe 2 minutes stuck with some of us very deeply. We were very enamored that how can something like this happen? For us, we had never heard of virtual reality. I mean, imagine, I come from a very small town in Bihar, and then I was in, Kharagpur campus, again in 110 kilometers away from Kolkata, again, a very remote area. No idea of what virtual reality is, but when we saw that 2 minutes of that cinematic, I would say, futuristic view, it was very enamoring. Wow, there is something like this happening in the world, or there is something like this possible in the world. And so that led me to triggered my I would say the curiosity within me to understand what exactly is that area, what happens in that area. And so, that drove me to basically, interestingly, I would say that at that point in time, and after I watched the movie a week later, one of the gentlemen from that, one of the DRDO labs called Center for AI and Robotics came to our campus, and he was talking about virtual reality. And so, again, because I was enamored by the subject, I, reached out to him and I say, I want to do internship in your lab, and I got my internship. And when I went for the first time to the lab, I saw some of these big machines. They were like your Godrej Almiras, those huge ones. And I was wondering what the hell it is. I mean, I was like, okay, in fact, my curiosity led me to ask this question to my professor or my manager, that what is this? Is this some sort of an Almira where you're stacking all the computers? And he said, yes, that's how you should think of it. I mean, because essentially it is a rack in which all the compute or all the compute powers are basically clustered together. That was my introduction to high performance computing. Because when you do anything which requires heavy computation, and when I say heavy computation, which means when you're processing a lot of data, when you process a lot of data, you require compute, you require storage, and you need a very good network if you want to get any sort of, let's say, near real-time or real-time information. So when you talk about performance, performance essentially correlates to something which you require, immediate attention. You require less latency. You require, information to be processed at a much faster and at a higher throughput, right? So when you look at it from that perspective, that is what all high performance computing is about. So my introduction to high performance computing was through computer graphics. And in computer graphics, you can look at virtual reality, which has become a big thing in the market today than what it was, let's say, 22, 23 years ago, right? And so if you look at it, what has happened from then to now, right? And interestingly, and this is something which I found was very, very apt and relevant. I obviously picked it up from the Eurolab 4 HPC website. And why this is apt is because when you look at, what I have seen in the high performance computing, over the last 22, 23 years is, the compute has become a lot more accessible and it is less cost prohibitive. So in the earlier time, and I'll give you some information on the kind of the system which we were working on in those days. The compute was much lesser than what you can get today on even a phone, perhaps, or perhaps a very high throughput workstations. And with the advent of cloud, the ability to scale your high performance computing has become more or less, I'm using a word, I'm exaggerating the word infinite, but that is literally true. You could auto scale your need, you could work with infinite capacity and computing ability to carry out what you require for high performance computing. Okay, so when you talk about cloud computation provided by today, the AWS, the the Microsofts, the Googles of the world, the IBMs of the world, and also the other interesting thing is the whole resurgence of AI in the context of where it is today has also propelled the desire for real-time analytics. So, for example, today, if you look at it, and I'm just throwing an example and how high performance computing has played a role, when you look at all the, all the pandemics which have hit in the past, of, any endemics or the pandemics which have hit in the past, it has taken several years before you could come out with vaccination. Okay. If you look at the current pandemic we all are encountering today, how many days or how many months did it take for the new kind of vaccination to come out? Maybe around 8 to 12 months. It used to take 10 years, and in some cases, almost 2 decades before you could come out with any kind of vaccination for these kind of, the pandemics like HIVs or the other ones in the past historic area. That has been enabled by this whole concept of high performance computing, because now you can crunch exabytes of data at a very high speed. You can bring in all kind of information. You can carry out all kind of I would say the sequential and concurrent experiments to identify what is right or most suited desired solution for your need. And that is something which will perhaps get even more better with time. Okay, so those are some of the real things which are happening. I kept saying real in my on the right hand side of my points, because these are really the things which we are seeing today. I mean, if you look at data deluge, which I just spoke to you in the last slide, look at the kind of data which is being generated, right? And with what we call as Internet of Things or industrial Internet of Things, we are now talking about devices becoming smart, And what does a device becoming smart mean? Devices becoming smart means they also generate data and they process data. So your ability to process data at what we call as edge and your ability to process data centrally is all going to be driven by high performance computing. So this is something which I wanted to kind of let you guys know. And obviously the other thing is access to users. This kind of infinite computing is also allowing the adoption and understanding that some of the problems which used to take ages to solve can be solved in a much more faster time. And so you can see that it's very nicely mentioned that there is a technology push and there is an application pull, which is essentially defining the next generation of high performance computing, right? So CMOS scaling, for example, right? I mean, this is essentially saying, how can you make your transistors or your ICs much more minuscule than they are today, right? Can you actually start looking at what you call as neuromorphic computing, which is essentially trying to mimic human brains? Can you actually get to that level of capability within the ecosystem, right? So those are the kind of things which are going to drive the desire for solving some of the challenges in the world related to high performance computing. Can we move to the next slide, please? So I just wanted to kind of give you guys an idea of what is high performance computing, right? So as I was mentioning that compute, storage, and network, they essentially form the three key component for any kind of high performance computing. Today, what is happening is another interesting thing is something called, which I was showing in the previous slide, is hyper-converged infrastructure. Hyper-converged infrastructure essentially means you're trying to bring compute and storage together. So if I can draw a very crude analogy is, let's say you are in some sort of a marriage gathering where, there is this chef who is basically having all his, utensils, all the gas cylinders, etc., to cook the food. But your key ingredients like flour or rice and all your vegetables and all your different items are sitting somewhere else. Each time you want to cook a new dish, you have to literally go out and fetch those ingredients and come back and cook. Imagine the kind of time it takes, right? Now imagine if all these things are in the same place, it becomes a lot more easier to do things at a faster speed. And that is what is hyper-converged infrastructure, which is now becoming a very critical component of this whole infinite computing, right? So if you look at, there are three key elements of high performance computing, right? How do you reduce your time to solution? So let's say if you look at autonomous vehicles, the ability of vehicle. So let's say, for example, if you're driving an autonomous vehicle, nowadays they provide you with a mechanism that it can sense an object in front of it and it can de-accelerate or apply a brake. Now imagine, an accident happens in a spur of second. Our previous speaker was talking about Shanbhangur. Like, you don't know what can happen in that second or microsecond or millisecond or nanosecond, right? Ability of a system to react and take action in that, very microsecond requires a lot of processing, which is happening between the car, which is, in the state wherever it is, and the server or the cloud server, where it takes the information, processes it, sends back the command or instruction to the vehicle to take an action. That requires a tremendous amount of compute throughput and information sharing back and forth in literally milliseconds or nanoseconds, not nanosecond, but let's say millisecond. That's the kind of power of compute which is required, and HPC provides that. Medical devices. I will tell you some very interesting example again from my past. When we were again back in 97, 98, when we were writing software for carrying out um, you know virtual walkthrough of the Himalayas, or the Kargil terrain. And this is, I'm talking about 1998, when Kargil war had happened between India and Pakistan. Our lab was involved in building a terrain which would allow the army men to understand and acclimatize themselves to the different terrains, because it's very important for you to know, because human brains are trained to look at objects and correlate with them. So for example, before GPS came, and if you had to look for Shuklaji's house, somebody will ask you, where is Shuklaji's house? You'll say, when you go to the right, you'll see a pink color house. When you go to the left, you'll see a green. So there were always those, those kind of, I would say, key points you would address, and then you would reach to Shuklaji's house. So similarly, you think of it that, to train your brain in those kind of terrains where, you have no such information. Let's say you're in Siachen. It's absolutely snow all over the place. How do you train your brain to think in certain? You can only look at some peaks and troughs in the contour of the land to understand what is what. And for us to compute that heavy amount of information, and these were all information provided by GSI, which is the Geological Survey of India, which would provide you three-dimensional information, which is X, Y, and Z, or Z as you call it. And essentially with that, we would create the surface mesh. We would wrap it with a satellite ISRO satellite image, and then do a walkthrough. And that walkthrough had to be real. I mean, in the sense that you cannot expect any sort of when you're trying to do a walkthrough, it has to be as smooth as it can get, which means you're talking about refreshing your screen at 60 frames per second. And these were not easy back then, because again, I was saying these were this compute was done by the beasts, these computer beast, which we used to have back then. But our ability to mimic and create what a human eye can do was very challenging. But today, it is there. It's not there because your human eye is very photonic in nature. So and even haptic, for example. Each cell in your body is a sensor in itself. To create that millions of sensor-based ability to get the right kind of haptic, feedback is also very challenging. But compute may perhaps get us there, and that is why solving the ability to defy Moore's law to create much and much more miniature-led ICs and transistors, which can actually provide you more compute with more efficient power management, is something which the world is trying to look at and solve those challenges. But those are going to be driven. So as you can see that, real time or reduced time to solution, energy efficiency. So when you're talking about all these different devices, how do you make them energy efficient so that, they don't burn out, they don't cause damages, yet they are efficiently running and providing you all the kind of information so that you can take smart decisions, right? Renewable energy. I mean, so for example, you're talking about different kind of material designs, computer-aided designs, right? I mean, how do you make your data center with less carbon dioxide footprint, right? What do you do? So there are different ways in which high-performance computing can be used to solve a lot of these problems. I mean, genomics is a great example. I mean, today, when you're talking about the protein processing of information to come out with the right kind of, the vaccination, it all resulted into this, huge amount of data being processed through high-performance computing to get you the right kind of information, right? I think those are the kind of things which you will start seeing becoming more and more, I would say, more and more prevalent, if I can, put it that way. Suman, can you go to the next slide, please? Thank you. So I just want, again, I took this from Hyperion Research. If any one of you want to get this data, I can share it with you. It's available on the web. But I thought this is very interesting and useful. Suman and I have worked on precision medicine in the past, and it was a very, very interesting kind of project on the artificial intelligence which we had done, where essentially we were trying to help the radiologists become better at their work by making sure that we could look at three-dimensional images, they call it as DICOM images, and provide auto segmentation of organs so that when they go for when a cancer patient goes for a chemotherapy or a radiotherapy treatment, then they should be allowed to essentially point the therapy or point the radiation at the right organ or at the right place so that other organs don't get damaged. Very interesting area. We can talk about this more later, but again, this is becoming more and more prevalent. Automated driving systems, I mean, it's a reality today. There is Tesla, there are all kind of, in fact, in the United States, they are mandating that by 2035, close to 80% of the vehicles should be, electrical vehicles. That is the kind of political will which is residing in this country, and Tesla is a great example of how they have created wealth and value, and which is now being followed up by the GMs, the Fords, etc., to take it to the market. Fraud and anomaly detection. I mean, this is huge when you look at, we all living in a digital currency world. The more and more digital footprint you create, that much more attacking surface or attack surface, I call it, you create, which means that you're allowing the cyber fraud, possibility to happen. And how do you basically, again, use the whole concept of AI and other technology to identify fraud and any kind of anomaly detection? Again, it's a huge area where financial institutions, anyone who has what you call as a personable identifiable information, PII, or critical data. I mean, look at Aadhaar or UIA, DAIA, or any of these. I mean, ability to expose your information is so high that how does government or how does organization ensure they protect your and my information, your and my data, right? It's extremely, extremely important. Affinity marketing, personalizable marketing means I know precisely, I understand you so well that I am able to direct you to the right kind of information so that you buy them or you consume them. That's another big area where there is a huge amount of data crunching which is happening. Then cybersecurity and IoT edge smart cities, as you can see, are the classic examples of where the usage of high performance computing has become a lot and accessible. Again, I keep repeating, accessibility of this infinite computing ecosystem has been very, very important to realize the dream of solving some of these problems as they come along. Suman, next slide, please. I don't want to go through this. I mean, I'll be happy to share this information, but again, this is just to kind of give you an idea of different industry segments where the high performance computing has already taken. I mean, if you look at geoscience and geoengineering, high performance computing was happening for a very long time. When you look at fracking data, when you look at the seismic data, the GIS, the mapping, these are tremendous amount of information. I mean, another area, I mean, agriculture. Let me tell you something which I have been part with some of my other friends. You look at what is happening in the space of food or growing food. I mean, the land footprint is reducing because we are expanding. We are, as population, we are growing, we are expanding, so we are consuming more and more land for our need. So the surface area for growing food or growing crops and all is reducing. At the same time, the hunger or the hungry people are growing at a very rapid rate. in the market versus the rate at which we are able to generate and produce food. How do you become more efficient in that space, right? How do you use technology to, make a barren land become efficient at growing crops, growing food, to feed these hungry mouth? And that is where, again, your ability to process soil data, your ability to, use drones to capture information about soil, understand what you can do, understand how you can grow, how you can genetically, perhaps modify some of these, proteins or foods so that you can grow them all the year so that you can feed this hungry mouth, right? So there are n number of ways in which high performance computing today is contributing to the growth of the society. I mean, we are obviously, attacking some of these areas because digital footprints is increasing, but there are these areas like curbing hunger through, growing more high protein, high, value food for feeding hungry mouth. I think it is very, very critical. I mean, if you look at India, for example, how do we help our, farming community become much more efficient, right? Can we do something in that space? There is already a lot of organic food techniques being used by a lot of learned people who are, using their learning, in different parts of the world and trying to bring that to India. I mean, can the government actually start looking at all this information and empowering the farming community to become a lot more efficient in using technology to basically grow food at a lot faster pace than they are doing right now. I think those are some of the interesting challenges which can be solved, and in particular, I'm very passionate about, because I believe that with all that learning and all that experience we have had in the past, it's very important that we give it back to the society in whichever small contributions we can make in whichever form we should. Someone to the next slide, please. And so what I wanted to do, I excite the young audience out here that this is a very, very growing market. So what has happened is, obviously, and I'm giving you some commercial information again, just to kind of let you process some of these information. The high performance computing market shrunk in 2020 because of the pandemic. Why? Because these workers were falling sick. The production of all these these servers were affected, and that is why you see a decline of 14%. But what they are saying is the CAGR, or the compounded annual growth rate, is going to be 6.8% by 2024, and that's again a big number, considering the fact that and again, this is an estimate, okay? So these estimates keep changing every year or every quarter. But I can tell you from what we are seeing in the market, the pandemic has caused adoption of digital by a lot of companies who were either laggards or followers. Okay? Now, as soon as the cloud adoption is increasing, these followers and laggards are also able to generate a lot of data, and data is no more fuel. It is IP. It is intellectual property of a lot of these organizations. And they all want to monetize, they all want to make money out of this data. Okay? And so what does it mean? It means that you have to process this data, you have to understand what kind of golden analytical information you can find out from these data you have. And some of these companies generate, again, like exabytes of data. When you're talking about exabytes of data, it requires, again, huge amount of compute. And today, ability of cloud to provide you that kind of on cloud compute is high. So a lot of companies are using that. but a lot of companies who are very sacrosanct with their data prefer to have high performance computing on-prem, which means in their own data center, so that the data resides within their own boundary. And that is the information I'm sharing, that if that market is growing, you should expect the cloud market to grow at least 2x of what I'm showing you here right now. So that is the beauty of this market. This is growing significantly. And this is being propelled by not this, you can imagine the infrastructure also propels the growth of software, the applications you build, the platforms which get built on top of it, right? So Suman, can you go to the next slide, please? Thank you. So I also wanted to kind of tell you that, again, in the reality, when you look at all these commercial usage of, high performance computing, there are a lot of factors which organization looks at when they're trying to buy these kind of, infrastructure, because they're not cheap. They're still expensive. I'm not talking about cloud-led HPC. I'm still talking about on-prem led HPCs, So, price is a very important factor. Application performance is a very important factor. Security, how secure can the environment be? How faster is your CPU? Can it handle AI and big data capability? And then, as you can imagine, as you see, that this is becoming one of the driving factors. So AI and big data is going to drive a lot of high performance computing workloads in the market today. And so there are a bunch of others. And similarly, you can see that, there are different barriers to expanding on the purchase. I mean, so, these high performance computing, if you're talking about groups or workspaces, they call it, these are cheaper. They cost a couple of $1 million. But if you're looking at exascale, kind of, these are like $400 million, servers. They're very, very expensive. But as you can see, they're looking at, power and cooling cost. How much do I spend on that? What is my space limitations? Moving in and out of my servers. And again, this is something to be looked at. Lack of knowledge, skilled HPC technical computing support staff, people, data science people, people who understand data, people who understand mathematics, people who understand, the data which comes from their own industry and process them. I think those are all very, very important requirements, which are inhibitors right now for a massive adoption. And I think once we create that kind of an environment, then we will see a significant, adoption or increase of such, all these barriers will go down. Next slide, please. And this, the reason I wanted to put this slide for all of us here, again, the young crowd, you should see that China leads the market when it comes to data-led IP. And basically, they are literally the leaders today. I mean, you look at it, they are talking about exascale systems, which even US doesn't have today. Okay? If you look at it, they are like leading by, 7 to 11 exascale systems, whereas, US is still talking about 7 to 9. Europe combined has 7 to 10, Japan has 4, and then, of course, other countries, which you can see, it's given a star mark, South Korea, Singapore, etc. And in India right now, when we look at, we don't have anyone. We perhaps CDAC or maybe Tata's are trying to build one, but they are not even there. And Tata's, in fact, have 27 petaflops system right now, and CDAC has much smaller. This is something I wish that, India starts spending, because wealth of information which we have as a nation, wealth of information. How do we turn that into gold again is something we need to look at. And so we need to, get ourselves as a superpower with all that kind of information, with all the kind of, data and rich minerals, all that we have. How can we become more, superpower? I think those are the kind of challenges we need to solve. But I just wanted to kind of share this with the young crowd so that that, you are going to be the catalyst for, and I would desire that, some of you actually drive India to be, closely comparable to Japan, or maybe have 2 or 3 exascale kind of systems as we, right? So next slide, please. And this is another data point I wanted to share is, and I guess Sumar would be speaking about, or he has already spoken about AI. As you can see that, there are a lot of HPC related, they call it as workloads, which means different kind of applications. But the one which is driving the maximum CAGR is, your AI, machine learning, deep learning kind of workloads, and that is 31.1%. So, your next generation of high performance computing would be driven by all these workloads coming from deep learning, and which we were talking about, whether it's genomics, whether it is ability of an autonomous driving car to take intelligent decisions like, lane changing, applying brakes so that, you avoid collision, etc., are going to drive a significant amount of HPC-led compute. So this is just a data point which I wanted to share. Next slide, please. And I'm going to conclude now. I think I've already consumed a lot of time. So this is for us to think about, right? I mean, whoever you are, whether you come from a field of economics, whether you come from a field of arts, whether you come from a field of STEM, as they call it, science, technology, engineering, mathematics, be very passionate about what you do. So I just wanted to conclude with some of my learnings, my mistakes. I had a golden opportunity in my very earlier in my career to be part of something which was very revolutionary, something very different. But then, I couldn't sustain my passion, and I was jumping from one to another. Whatever area you take, make sure you are deep into it, make sure you do excellent, and make sure you do very well. Whatever be it, whether you decide to do something in arts, or data science, or engineering, or mechanical engineering, or aeronautical engineering, whatever it is, stick to that and do the best. And I think in each of these areas, and as digital becomes more and more part of us, we start creating a digital twin of ourselves. Our ability to embrace technology for the right things. So when I say right things, for example, alleviating poverty, for making sure we grow more food for a hungry mouth, our ability to use technology to reduce crime. I think those are the areas where, if we can contribute significantly, I think that will be redefining who we are as a nation. And with that, I just wanted to conclude. And if anyone has any questions, I'm more than happy to answer. Any questions?
The interns can use chat box also. The interns can write their questions on chat box if they have any.
So Sujay, there was one comment from Chaitanya talking about CDAC to commission India's fastest HPC AI supercomputer. And he has a question on how do we learn more about HPC. Sujay, do you want to take that question?
Yeah. So there are different ways to look at it. I mean, if you want to do some level of self-learning, there are courses available in Udemy and other places. But I can also point. I don't know which universities. So I know that some of the IITs are offering, or ISC, in fact, ISC, Indian Institute of Science, offers some courses on high performance computing. So I'm more than happy to share, Suman, with you so that we can distribute that with the, with the students out here so that they can look at it and figure out how to apply or be part of those courses.